with the phone. It's much easier with the computer because you have your hands free, but well.
With the computer it's easier, but sometimes the quality is not good with the computer, so we don't have choice than
Right.
to go to enough to escape. I don't know. Oh. Why start from the beginning? Okay, I see. For today is to get information of the discussion are telling me that we have to get this overview because some of you are missing the missing the connection. So we have this to get the big picture before going to the details. So some of the I'm going to go very fast about classification and the thing we are studying in the last 3 weeks. First, something we have started, but we have not completed yet. About classification and prediction. We're talking about 2 big classes, supervised and unsupervised learning. In the supervised learning, which is the classification we have been covering in the last 2 weeks, we're talking about that we have the training data, the observations are given in the input, we have this data set, and data set is, in addition, contain the class in which we can classify the observation. Supervised is because we have on beforehand defined the class. We are doing the training with this given data, the classifier in the way it will classify with the set, and any new data after the training is accomplished will be classified according to the, let's say, to the accuracy of training we perform to this classifier. Other class of classification is the unsupervised learning, in which we don't know from the input data what classes are. So we're going to focus on the unsupervised learning in 2 weeks. After the midterm, we still have supervised learning, 1 more week in continuous data, which is regression, and then we go to what is clustering. So on hand, the classes are not defined. That is the simplest definition of unsupervised learning. I would like to point is not moving on. Okay. Regarding, you are hearing different words used distinctly, classification and prediction. In mind, of course, 2 different things. From big picture, classification is just you, from the given data set, you're capable to classify them in certain class. And prediction is to predict what this class can be. So you see, in this sense, we can use them indistinctly. But in addition, prediction is used in a sense, we talk about categorical and continuous variable. So sometimes the distinction between classification and prediction in many of the text articles is even because prediction is mostly taught when we talk about a regression, when we talk about continuous variable. So keep this in mind. Sometimes in the context we are talking about classification and prediction can be used indirectly, and they mean exactly the same thing if we talk about categorical variable. But prediction is strongly used when we talk about continuous value function, when we use, for instance, to predict the value of a function, which is a continuous value. So keep this thing in mind when you reading different reading, because I see since internet is full of information, sometimes we are tempted just to search and read whatever sources we find. Sometimes the sources are not reliable, let's put it this way. And sometimes you get more confused in all these sources than just relying with sources like the one which are suggested in the classroom, discussing in the classroom, or doing research with journal which are, let's say, reliable resources in academic environment. Let's go to the next step, which is what we understand by classification, and you already are aware of this. You worked the previous week with the decision tree, that classification is a two-step process. We have to construct the model, and we have to train with the data set, with the training data set. We have to train them in order to get the desired result. And we use this model, that is already trained classifier, to classify, let's say, data which are not available during the training process. I mean, with operational purposes, with the purposes for which the model was constructed. So it's very important that you keep this in mind, that when we train the data set, we try to estimate the accuracy of the model. So accuracy of the model is not, we have, in addition to the training data set, to have test data sets which are going to permit us to estimate the accuracy of the model. What is the accuracy important when we talk about classification? Well, the main aim of classification is to classify some data reliable. So accuracy, of course, should the first filter we should look. Keep in mind, in order to get the accuracy, and we need to use two different, let's say, input data. You have a data set. All the problem you are doing practically, you have just a single data set, right? And for this data set, you take a portion of the data to train the classifier, and other portion of the data to test the classifier. There are many different methods how to do this. You already have explored practically some of these methods, and we'll be exploring more in the next class. So, regarding the most important to evaluate the classifier is the confusion matrix. I asked to do this in the previous week, and you did excellent. Some of you, by observation and by the Turnitin assignment, are not very clear about the meaning of the confusion matrix, with the main way we evaluate the performance of the classifier by accuracy, sensitivity, and specificity. It's important. It's important when you classify to have how many of the given data are classified as true positive and as a true negative. These are the results we are looking for, and they are in the diagonal of this matrix. So which are not in the diagonal of the confusion matrix, are the false negative and the false positive, are not desirable for any classifier. So when this value in the confusion matrix appear high compared to the value you have in diagonal, that means your classifier is not trained well. So perhaps you have to go back and to some of the parameters of the classifier. So the main confusion matrix are the true positive and the true negative, which we are concerned about. The other two parameters are parts which are giving us insight about the error rate and about the specificity. So you see the accuracy is the most important metric we care about any classifier, and this is the. I think some of you are not in mute and we're having some trouble. I'm not going to return to the previous slide, but just want to stress out, this was not just for specific assignment. This I think you have to keep in mind for your research project. And for let's say for the main thing you learn in this one. So that's why it's so important. That's why I select to focus on this. Other important you should keep in mind when you do your research project, and that you will have to, in the research project, you will have to compare different models. That's the requirement for the research project. And following up in the next few weeks, you will be defining which two models you will be using in your project. And one of the things is to compare the model, which one is better suited for the solution of this problem you are trying to solve. So, one of the things we use to compare different models is the name ROC curve, which is receiver operating curve, and it's very visually represents the false positive value, which is in the horizontal, and the true positive rate, which is in the vertical. So you see, the curve, if it's inclined to the vertical, is better performed. So now in this graph is showing us that this is 50-50. You don't want a classifier which is going to classify 50-50, right? So what we want is the graphical presentation is very easy to understand and interpret the performance of your classifier. So the performance of classifier, besides accuracy and besides the ROC curve, which is very good indicator about accuracy, we use different other parameters when we select the, let's say, the viable model for the problem we are trying to solve. These are train time, roundness, scarcity, and many others. So keep all this in mind when you select the model and you explore them for the problem you are solving. This is like an overview what we have been doing. I would like to give you some insight about the neural network, because I see very, let's say, it's not very clear when I look the responses in the discussion. So that I decided to do this clarification about the nature of the neural network. Of course, this is a topic we can talk about hours. Just I want to go behind the scene so you can understand what we are talking about and why and for what this model can be very useful as a classifier. The problem about previous week with decision tree, classification, and bias for certain type of problem, they form very well. But when the problem is, let's say, very complicated, and we don't have, let's say, clue out any rule we can apply to this, the different rule base are not going to work okay. In addition, if the variables are not independent, recording the bias theorem, they are not going, the Bayesian classifier is not going to perform okay. So neural networks are very, let's say, robust. They perform very well for nonlinear, highly coupled problems, which cannot have the solution, let's say, very easily expressed neither in mathematical equation, neither logically as a rule. So they perform okay even for discrete or continuous variables. So you can use them more universally in both cases. Actually, they perform for any case. But why? So that is why I want to go a little different. That book, even starting the same way, you can understand the why of this, and then you have better decision about your research project, what to do, not only about the specific assignment you are doing this week, in which Elena is going to help you with the R. After I'm finishing, she's going to go with the assignment and with any question you may have. Now, here is the why of the thing with the neural network, which I would very like and see and think are very useful that you understand. The base of this is coming, of course, from the brain, the where it function, and translated to the computer. Our modeling in computer is sending in this graphical way, and the units, starting, let's say, with the building unit, the simplest building unit of a neural network, the neuron, we can think about unit perceptron. That was the neuron, or unit perceptron is the same. In this case, we are talking about all the inputs with different weights. You see here V1, W1, W2, Wn are added by the summation, and then you have some which is x0, which can have different values. Is for the purpose of the training very useful, and you will see that. And then this pass to a function. This function can be different. In this case, we are talking about the simple function, which is sign, which can be 1 or -1 according to the result of the summation, and that's going to perform and is going to give you the output. You see, very simple model, but let's see what you can achieve with this. Slide, what is named backpropagation. I'm to return to backpropagation later, which is a little more in detail. And for the network, we are going to work exactly the same way as a classifier. We are going to have the test data set and have the training perform with input and the target variable. So what we are doing in the neural network, we are adjusting the adjusting these weights. That's the learning. So we have the training data set, which contains x1 to xn. They are neural network to the single neuron. The operation is performed with some initial, maybe they are just random weights. And then the output. Output is compared. Output of the network is compared with the target variable. So you get the error. And this is exactly where the backpropagation goes in place, and is the error between the target and the output, and this data is applied back to adjust the base. And again, with new weight, you obtain and you calculate until you know how you're going to do this. Say the algorithm is conversion. Algorithm is conversion until you get to some error, but there are other issues which solve this with simple model. Your training is going to convert. The issue which is named linearly separable. I want to go to this issue which is very important beside the practical thing. So again, here you have graphically represented what we are talking about learning, which is classification. Input data, the output is compared with the result of the neural network, and the backpropagation is the training process is in adjusting the weight. Now, here's one numerical example which you can see. This example exactly doesn't correspond to this because you can have, I can see three different classes here. In order to have three different, if you're going to have two classes, you can have just one output and 0 and 1 is going to give you output. But in order to get three classes like here, 0, 1, and 2, you need to have three outputs. About the architecture of the network, I will point later. Here is the how we train Perceptron for a very simple example, which is the logical AND. We have the different input which are going to be given to these two, and then we have the bias, which in this case is with the weight 0, 3. And then we are doing the training, and our target in 0, 0 is 0, in 0, 1 is 0, in 1, 0 is 1, and 1, 1 is 0. So we see that this way, after training the network, we're going to obtain the desired output. So the propagation is exactly to get what this weight has in order to get the desired output. This is a simple example, which of course can be perfect in Perceptron with the simple sign function. Different, let's say, a parameter which you are using exactly in your practical practical exercise you are doing this way of the learning. And regarding this problem, you see that all possible data we are training are these four data sets: 0, 0, 1, 1, 0, and 1, 1. So again, is presented what we are talking about, the learning algorithm. We have the target value, the output value, and the backpropagation. What is going to calculate is the error between out and target, and is going to adjust. Simplified backpropagation. Backpropagation algorithm you can find mathematically formal, well described in different book article. I would like you to get the big idea of what is backpropagation about. So this is so coming from mathematical background, but it works perfectly because it's very logical the way the classifier works. You adjust the weight till you get the desired result in general. I want to point here on something which is the way when we classify, we have something named decision boundary, And it can be linear. Let's say if two classes are linearly separable, you see the graphic is very simple, and you can imagine that there shouldn't be a big deal of a classifier doing this. But other problem, like I have on the right hand, you see this problem is not linearly separable. So the first one corresponds to the logical function and they are totally linearly separable. So we saw how we can train the network and obtain the desired result. But in case of exclusive OR, we have a such linear boundary. So you see that we have to go to more complex architecture of network in order to serve for problems which are not linearly separable, like the exclusive OR. I have here the exclusive OR. And the way we train this network in order to obtain the desired result for the exclusive OR. The boundary here is not linear, and here I have very nice graphical, let's say, a representation of the different problems, which is very abstract and mathematically it has mathematical foundation, everything which is here. But the main idea is not to make your more difficult to understand, is just the opposite. The aim is graphically to interpret and to understand. When you see all this architecture of neural network with several, let's say, layers, hidden layers, why they are. The problem is you choose a single layer, only problem which are linearly separable, like the local AND. When you go to problem like exclusive OR, when you cannot do this linear separation, obviously you cannot solve this problem. You have to go with other architecture and other function. You are going to be wondering why I end here to 3 layers. Why not more than 3 layers? Well, the statement, this has a mathematical proof. With 3 layers, actually, you can approximate mathematically any function. It's more. But from practical point of view and experimenting with different architecture, during last 20 years, neural network has been around in number of the hidden layers may give you better results. So this doesn't have mathematical explanation, just practical, and work for some problems. So keep this in mind when you work in your problem. That in order to solve linearly not separable problems, which are more complicated, not linearly highly coupled problems, in the input variable and the target variable, we have to go to some more complex architecture with labor is one of almost any problem. In addition to this, besides the number of layers, when you design in the neural network, you think about the activation function. And they are different activation functions. We are going to give you, and I'm going just to show them graphically, and intuitively you understand why one should be better than other. Why sigmoid function should be better? Well, when we talk about the left hand, the sign or the step function, we're talking about if you go to the brain, you have just this single response, yes or not. And in data, you even can go overexcited the neuron, and then you can get totally incorrect result. When you work with smooth function like the sigmoid function, the results are going to be much better. So keep in mind, when you try to decide which neural network architecture is better suited to your problem, keep in mind the activation function and number of hidden levels are actually the Q parameter you can play with in order to the result. And actually, what is better result? You talk about the accuracy of the classifier, if the network is going to perform as a classifier. Just thematically, you learn this in many places, and why we are looking to a differentiable function for the activation function for the activation. Just backpropagation is a gradient. Let's say is gradient function. So you need to differentiate the function. That's why you will say, why this function and not any other? Why sigmoid, why tangent? Because they are simple differentiable. And in order to do a backpropagation, you need this. I don't want to do this more difficult. Just I put this, let's say, this slide in order when you do different readings, you understand the why of the thing. All I have in this review, I proceed with question. Perhaps better to give the Elena, or if there are any questions. Let me see if there are questions in the chat. I see question in the chat, so I think we proceed, Elena, with what you have on the exercise this way, and then we respond question. I'm passing the control to you. Okay.
Can you hear me?
Yeah, exactly. You can post your question in the chat. I'm looking to the question, and Elena is going to give you some insight in practical exercises. So to connect the one thing with the practical thing, and you can connect the dots.
Screen, right?
You have to go and share your screen to the top.
I go share and I hit my screen. Yeah.
Okay, good.
It's taking time to come up. This way. Okay. Going to our studio. Oh, I already have it open. I'm going to close this. I'm going to start all over. You hear me okay, right? Do you hear me?
Yes, perfect.
Okay, so I'm going to go here. I'm going to import the data set. And I'm going to say from text file. I'm going to go to the folder where I have my data stored. And this folder data set. And I'm going to do it on the created data. I created a open. Here, it's giving me an option, and I want to select the yes. I have to keep my variable names. What else I want? I want to make sure that if they're empty values, I want them to be coded as NA. Okay, here we go, and I'm going to click import. That's why to import your data. All right. So here is the created data, and what I did was in the initial data set, this class was as plus or minus. I manually changed it in Excel before importing the data here. And it's big because I don't want to make this problem complex, so to speak, when it's in our own network. Now if you run the summary command, you're going to see that this data set has missing values, right? I go to this summary, and I do this credit. Okay. Now just keep in mind that R is very case sensitive. So I do it the same way here. Now it has missing values, and the missing values, and the neural network missing values are a problem. So what we're gonna do is we're going to replace the missing values with average. So you don't need to do that. You're lucky that you don't need to do this on your homework exercise because I picked the data set without missing values. But you do need to know how to do that for the project. Another issue we have here is that your data has both. It has categorical variables and it has the numeric variables. So here is the trick because neural net method, it does not like categorical variables. So I'll show you how to deal with it. But first, this is very important. We need to get rid of missing values. So prepare the script ahead of time. So I'm going ahead and copy my first command here. Control C. Control V. Command is going to do is this. I have variable A2. Variable A2 has 12 rows with missing values. And I'm going, since this variable is continuous, I can go ahead and I can replace it with a mean of the. I'm replacing it with a mean. Okay. And now I have to deal with one more. This is 15. So the way to do this is I have the upper error, and I can go ahead and I would need to change over here to 14. 14, right? I'm going to change it to 14 here. What I'll do is I hit enter here. The reason I like summary commands is because you want to verify that values have been handled, and they are. I don't see any more names. So next step, what's going to happen is if I do neural network right now, I'm going to get an error actually. The problem is because I have the categorical variables here, it doesn't like it. Everything has to be numeric. So what I'm going to do is I'm going to build a matrix. Here, basically, if you have to do that for your project, you can go ahead and copy my code right here. I'm going to pause this if it helps. And you go ahead and copy this. And instead of your data, instead of my data, you're going to put in the name of your data set here. So build a matrix, and I'll show you how it looks like shortly. Here, the data set is going to be my credit data. And what it's going to do is actually it's going to take my categorical variable, and it's going to create a separate variable for each value of the categorical variable. This is really tricky. Okay, I'm going to hit enter. And now what I can do is I can do this. I use my head command, and I'll preview what it looks like. Maybe let's see what it did. So it's here, for instance, A13, right? A13. What it was, it created a separate variable and values of the P and S. Here, the valid values are P, S, and G. So back here to the output of the summary command, that for in, right, G, P, and S. So what usually it tries to pick the most dominant ones. And it's a separate variable. And for each row, what it does is it looks For instance, number 13, the first row is visible 13. The first row is G. So in the treat, it's going to treat as 0 because it's not P. We created a separate variable of the two dominant values, which is P and S. The row here is not P and is not S, so that's why it's 0. But number 4, it's looking at the row here, and if it's S, number 5 rather, number 5 is S, so the 8 in S is going to be set to 1. So for each categorical variable, it creates, for each categorical variable, for each value of the categorical variable, it's creating a separate variable here. This is very important because you're going to need to do this on your project. Lucky with a class variable because it only has 2 values. So it's good news. So what I'm going to do is I'm going to feed my matrix inside the data set into the method function. I prepared the script beforehand because I want you guys see me typing all of this. So here we go. And we. Now we can time, and is it going to converge? It converted before. If it's not, then I'm going to try the different number of hidden nodes. See, it worked. What I have here is the first part is a formula. Class is my dependent variable, and I have to list. I know it's a lot of work, but I had to list all of these attributes that I'm going to use here using one layer with 4 nodes. And this is very important. When output equals false, it means that I want to do the classification problem. I don't want to do prediction, I want to do classification, right? So I'm going to look at my results. What is n? N is a variable where I store my output, right? So important, in the beginning, there was a video that you were asked to watch because n is a list variable. What I have to do is, I have to extract different components of it. I'll go this, and I'm going to go n. So now it tells me the different parts of output that I can look at. All is the functions that we ran to get our model, right? So look at the weights. I can look at my initial weights. This is the whole data set that we use to run this method. And then look my initial weights and so on. So in order to look at this, means this $sign. The nice thing is that when I type this, like for instance, sometimes an option, sometimes there's something called type ahead. It gives me a drop down. Oops, object not found. Well, here option, another thing I can do here is I can just do this. Oops, see what the problem is. I have to do NM. So this I have to do NM, $, and this call. See, this is what I was doing. I was typing the wrong variable name. Show me my function that I use, right? And I can look at the weights. This will show me the final weights. Yep. Give me my final weights. I know it's a little bit complex, but it's going to show me the weights for each input node, for each output node. This will make more sense when I plot the network, actually. Basically, what I could also do is I could do N. It's going to print the out to the screen, but see this, it's not giving me the information I want. So then I have to do, I have to see which components, so to speak, of an output are available. right? So they also look at this, and important. It shows me the values that I used as an input. This is very important because we're going to use this shortly to do the predicted values. We do the predicted values and compare it with an actual values. We're going to build confusion matrix. But before we do this, let's plot quickly this. So this is how it looks like. It's very difficult to read. So what I'm going to do is I'm going to do zoom. But see those weights that we saw before, these are labeled over here. So here I node, and the line that comes into that node has weight. I have an intercept, which is some kind of like a bias, so to speak. Close this. What I do right now is we do the content matrix, but to do that, this is a little bit complex. I build the prediction, do for the covariance part, is the data that I use to build the model. So I am covariate is my data that I'm going to feed right now. Compute function, I pass the model with a parameter, and I pass the data we use, and this one, and net result is a pool the actual predicted values. And see what my predict is. 0. But the problem is, what it's doing here is giving me the probabilities only. What I need to do is I need to round this. I'm going to round this, and what it means is if this 0.5, that is a 1. It's approved for the credit. And if the probability, if this is below 0.5, then it's going to be 0. So what I have to do is there is a function called apply. So it will like a loop, so to speak. My prediction apply and around. So I'll do it here. So basically how you round. If I look at my predicted values, as you can see, so for the first one, the predict is 1, and I see here from my data, the actual is also 1, but it may not be the case for all of these instances. So what I do is I have to build the confusion matrix, and the function to do this is a table. So I'm going to take this, and I'll do what I'm doing here. Control. The first input is the predicted class, and this actual class. I'm taking my data set, and I'm in this column right here, and I'm going to build the cross tabulation. 0. So here it's telling me that 0 instances, so 154 instances with class 0 were predicted as 0, and 195 of class 1 were predicted as 1. So to the classification accuracy, these two numbers, I'm going to divide by the total, by all numbers in the matrix. That's going to give me my accuracy. So again, once again, I'm looking at the diagonal. But the part is, you want to make sure that you remove the missing values. Otherwise, this command is not going to work. Because you build the matrix, these missing values get omitted. So this command to work, you have to have the same number of in my predict and the same number of values right here. Right. that you understand this, and I'm going to pause this code, because you're going to have to use the similar method if you're using the German credit data. If you're in a phishing website data, you need to use the same. And also, I believe it's cartography. I have to check if it has 3 classes or 2, I don't recall. But if it has 2 classes, you're going to use this, right, in your method. But do questions on this one? Questions? Do you hear me?
Yes.
Yes, I hear you.
Yeah, we can hear you. Okay. Did it Did the example make sense?
Yeah, it made sense.
So basically, this is a little bit harder than what you're doing in the homework. What I did was I just added extra step. You just need to build the matrix. The one in also another example, I called it advanced, because if you look at the cars example, there is an extra step that you need to do. Let's put cars. This is an example. Because here the problem is, with my cars, it does it has 6 classes, so you have to do extra steps in here. You're going to have more than one dependent variable. You're going to have more than one, because you have the symbol in has values in here. So each one of these becomes a separate dependent variable. So see how the formula is going to look like. You have a separate variable for each one of the class. So here, what I'm doing is this is how the are going to look like. If in value is equals 1, then you're going to have 1 in this column. It's equals 0 for the corresponding instance, it's going to have 1 in here. Instance 10 is going to have 1 here. This is response variable. So 9th instance symbol is 1, and it's going to have 1 in this column. If it's neither 1, neither 0, neither -1, then it's going to be 0 in all columns. What is M1, you might be wondering? This is what happened. The value was -1. It didn't like it. Neural network is very picky method. It did not like it. When it creates a variable for a separate value, it concatenates the variable name with a value. It did like symbol in -1, so I had to rename this. I had to rename the variable. And I do something more complex in here. And in here, I have to set the linear output equals false. Matrix, it's going to give me all my coefficients. And it's going to say the coefficient that, if you globalize the model, it's going to say the coefficient that on the line goes to the second layer nodes. Yeah. So these are coefficients. I'm scrolling down, and here is an explanation of what I'm doing here. And so on, I'm looking at different, so network visualization. This is very difficult part. I have to go to the GitHub webpage, and I have to download the package to this network, because the regular plot function that comes with R, it can have several output nodes. So I have to go to the GitHub, and I have to download this part here. And that's got several output nodes. In order to do something like this, you need to download a special package from GitHub. And I knew how. So this is really tricky, because the prediction, it has several variables. But I need to know I know which is a, I need to have one. I need to have only one output variable. So his function is gonna create the index is going to say if my first variable is a 1, or if second variable is a 1, or a third variable is a 1. Index is going to be actually the sort of like a symbol in value. This is the logic I'm using to determine the predicted value. I don't know the predicted value. I don't want to know if my first variable is 1. I don't want to know if my second variable is 1. I want to know my actual value to do fusion matrix. So this is a very complex example. So if you have more than one class, you can do this, or you can use an alternative method, right? But it's advanced, but I still put in there just in case you're interested. And if some of you want to do this, yeah. This, again, I had to go to GitHub to download this package. I found the solution online. It takes a little bit of research. But I put anything like this complex for the homework assignment, but this is good to just explore. What questions you have, guys?
A question even in the chat if they don't want. Well, I think maybe you guys started intensely working this assignment in the week. Of course, you still have time, but think about that today is Saturday. And just to wrap up, what talk at some point is like a disconnect with the implementation in R regarding the variable, regarding discrete and continuous. That what I talk about is in general about neural network, and this is very specific implementation of software. Any software has its own restriction. And also keep in mind, when you think about only two-class classification, everything is much simpler than when you have more than two. So, don't get overwhelmed. Then keep all this in mind, mostly for your research project, because a major assignment for the class.
I was going to, you guys look at the week 4 course count. There is the output posted in there, and it goes over different classification methods, and it actually shows example for each method on the iris data. So a good one to just use it as a guide. It shows you what each method does, and it is a good idea to select the method. There are different ones. There is naive Bayes, there is the forest, different representations of the trees, and different regression methods. So that, yeah. But it's very important to start early. There's a question about the comment. Oh, this comment, I'm going to pause this, sure. Comment works for this specific data set. If the set is different, there could be slight variations. But neural network, keep in mind, you want to get rid of the, you want to do all missing values. This is very important. Otherwise, when you build your matrix, the matrix is going to omit the rows with missing values, and you have some problems with the dimensions when it's time to build the matrix. So keep going to. And also try running this on a subset of variables. Like the code ahead of time, because you do not want to waste your time on sitting and typing this. of typing, right? All of these variables you have to type manually. Some methods they accept the wildcards, but not this method.
Okay.
What?
Understand how that what you did works on this set, but different variable sets would be different.
Different data set could be different, but well, basically what you need to do is you first understand the big picture. What I need to do for that data? What are the steps to analyze it? Or my first step would be to remove missing values. Write that down. You write down the steps. Then you go back and look up the commands to each step. You go to examples and you take commands. But you need to get an understanding of what am I going to do. Step, I need to remove the missing values. Let's go to Yelena's example. How does she remove the missing values? And you're going to go here, you're going to look at my code. Here she is doing this. And what is this? This is her data set name, the variable name, right? So what you could do is you're going to put your data set name, your variable name, right? And you go all the steps. First, you need to know what you want to do, what you expect to happen. So run this command, when I run it, I expect to see more missing values, and I want to replace my missing values with a column mean or mode. If it's a categorical variable, you want to take the mode. So, or if I want to remove all instances with missing values, that's possible too. But you need to first write what you want to do, and then you look at our commands to do that. That's different, but the syntax is going to be almost the same. That is a syntax, but you have to know what you're doing. Yeah. Okay, this is say that makes sense, of course, yeah. I'm glad it does. Because, I mean, yes, I picked something simple because you need to understand how to do something simple first, and then go back to more advanced stuff like this. So this is not as advanced as the cars data, but yeah. Well, I think about when you do the regression method, the nice thing about it is that it breaks down the delete variables for you. You're not going to need to do this matrix. The method is taking care of it for you. That's a nice thing. What the regression, but not the neural net. You have to do that step, unfortunately. Yeah. Any questions? Recommend for your project to not to wait until last minute because you might get stuck with R. And of course, if you're waiting until the last minute to do it, you're going to be thinking, "Oh my God, this is due tomorrow," and it's going to be harder for you to focus on actual analysis. So don't wait until the minute in case you might get stuck with R or something like that. Right? You don't want to wait until the last minute because R sometimes takes some time.
If there are not more questions, I think people should start working, and always they can ask in the classroom, and we should end this meeting if there are questions. Okay. So I'm ending the recording and ending the meeting. And have a productive week. Bye. Thank you.